Hello again, further students. In this video, we're going to go through another transformation. This one's an example of a log transformation, and again, we're going to be using our calculator to do a lot of the legwork for us. This one also involves sketching some residual plots, which is something that wasn't covered in the previous example. So let's get stuck into it. Again, we're given a set of, original data. We have some x values and some y values. And the first thing that we're asked to do is to sketch a residual plot for x versus y. So we're going to go into our statistics screen, plug the x values into list 1 like we always do. And plug the y values into list 2 like we always do. Okay. To create a residual plot, we first need to generate the residual values for x against y. And to do this, we go calc, regression, and then linear reg. Now, at this point, we haven't done any transformations, so we keep x list as list 1, y list is list 2. We want to copy the residuals into list 4. At the moment, we don't need that equation, so we just click OK. And if we tap across to list 4, we should see that we've got some residual values appearing there. To generate the residual plot, we go into our graph settings, so set graph and then setting. The type is still a scatter plot, but we need to make sure that our y-list, our y-axis, is going to be list 4. With a residual plot, the y-list will always be list 4 because that's where we'll always put our residual values. When we hit set and tap the graph button, we get a picture of our residual plot. Now, you might notice there's a regression line drawn there. If you don't want that line to be there, tap back up the top here. In your graph settings, down the bottom, you can tap previous reg and untick that box. And if you tap the graph button, that line will go away. All right, so you can see we've got this residual plot. It's a funny looking residual plot. It does have a bit of a U shape to it, although it's not a symmetric looking U shape. But certainly there's enough of a curved pattern there to indicate that this relationship doesn't look linear. Now the question's asking us to do a quick sketch, so I'm just going to cheat a little bit and copy paste that in. And does the relationship appear to be linear? Well, no, because there is a clear, and you can even use the phrase U-shaped in inverted commas because it's not really technical language, but there is a clear U-shaped pattern to the residual plot. Okay, the next part of the question, perform a log x transformation on the data and complete the table above by filling in the transform values along with the residual values for log x versus y. So we're going to do the transformation and then fill these values in. Okay, we always use list 3 for our transformation. Again, we're going to use this cell at the bottom of list 3. And this time we want the calculator to take the log of all of the values that are in list 1 because we are doing log of x. And so to do that, we firstly, in the Math 1 part of the keyboard, use the log 10 template, so it's log 10. And then in the ABC keyboard, we do list 1. So it's log 10 of list 1. When we hit execute, we should get a group of values appearing here. You'll notice that taking the log of these values has really had the effect of compressing them. So numbers like 400, 600, 1000 are now 2.6, 2.8, and 3. So it's really compressed the values down. That's the impact of the log transformation. All right, so let's fill those values in. Got 0, 1, 2, 2.6021, 2.7782, and 3. Okay, to get the residual values after the transformation, we go calc, regression, and linear reg again. But this time, we're going to use the transformed values, and it was the x values that changed. So instead of being list 1, we now set x to list 3 because that's where the transformed x values are. We didn't make any transformations to the y variable, so we leave that as list 2. And we're going to copy the residuals into list 4. We hit OK. At the moment, we don't need the equation or r squared, so we just click past this screen. And we should see, if we tap across, some new residual values in list 4. And these are the values that the question is asking us to copy down. So we've got negative 0.011, 0.0652, and so on. Okay, in part C, the question says sketch the residual plot for log x versus y. So we're going to redo our residual plot after the transformation. Again, residual plot, we go into the settings. Okay, our y list needs to be list 4, which is our residual values, but because we changed our x variable, we're going to change x list to be list 3, and this will give us our new scatter plot, our new residual plot. So we hit set, tap the graph button again. You'll notice again that that line has kind of appeared there. If you don't want it to be there in the graph settings, just untick previous reg and redo the graph. And that's our new residual plot. Now, the values are seemingly scattered around pretty randomly. There's certainly no more of that U-shaped pattern that we had going on in the initial residual plot. So it's seeming like this transformation has been effective in making the data a little more linear. So to me, it doesn't look like there's much of a pattern to this residual plot, and I'm going to say that this relationship then appears to be linear. Okay. Apparently my professional folder has failed to sync. You could ignore that. Okay, so the transformation appears to be successful. We've made the data, or the relationship between the data, linear because our scatter plot now looks a bit more randomly scattered rather than having that sort of horseshoe type pattern. Again, if you need to look back at anything through the video, rewind it and watch it again. Otherwise, good luck with your questions from 5C.